Okay, so welcome back to a new video. So in this I am going to show you all the orbital mechanics at least I know that are applicable in a 2D app. So these are used in real life by space agencies. So let's begin. So now this is the first position known as progress. In this position, the engine of the spacecraft is always away from its movement of direction. So in this case, you can see by this arrow that the spacecraft is moving like this in the Earth orbit. So the engine is pointing exactly away from it. So this position is known as progress. Now, for example, the spacecraft's engine is pointing towards the direction of motion. This position is known as retrograde. So when you fire the engine while in retrograde position, look what happens. When we fire in retrograde position, our speed decreases because we are firing opposite to the direction of movement. And if we fire prograde, which means like this, and now we are pointing to when we are pointing towards the direction of motion, and we fire, the orbit increases because our speed also increases. As we are firing like this, more speed is achieved. So this is known as firing prograde, and the other one is known as firing retrograde. So now I will show you types of orbit. So first type of orbit is low Earth orbit, the kind of orbit we are in now. So periapsis and apoapsis is low. So the next type of orbit is geotransfer orbit. It is used when we have to transfer a satellite into a geostationary orbit. I will explain that now. Okay. So now I will put the spacecraft into a geotransfer orbit, or it is known as GQ, and the low Earth orbit is known as LEO. So the kind of orbit this satellite is in is known as geotransfer. I will put our satellite into a geotransfer. So this type of orbit is known as geotransfer orbit. Now I will put it into a higher orbit. Notice how even using the reaction control system, the gas nozzles gas which is coming out of this nozzle which I am using also affects our orbit. Okay, so now I will put it into a higher orbit. For that we will have to time watch till there. And now burn progress. Now this is higher orbit. It is high above the Earth, that's why it is called as higher orbit. So now if the period of your revolution matches with the speed of Earth, if your speed matches with the Earth's speed of rotation, it is known as geosynchronous orbit, because due to this the satellite is always on above a single point. There are many satellites in this type of orbit, as they help to what we call, for example, if we have to give internet to some place or specifically, then these types of orbits are used. So now the next type of orbit. For example, now I am going to the moon. So now, while going for going to moon, I will have to increase my speed at the right time. For that, it takes a bit of time to load. Okay. So now, for example, this satellite is going to moon. So now we will have to increase the speed at the right place so that we go into a moon trajectory. The next type of not we cannot fall in orbit, but I will call it. The next type of the next subject in orbital mechanics is a trajectory or an injection. Injection means not those injections which we see when we go to medical. So now, as you can see, we are going near the moon. In the moon's sphere of influence, means where gravity is the strongest. So you can put satellites in. So now we have got a trajectory like this. This burn is known as trans-lunar injection, and this is the trans-lunar trajectory. So now we will use the same orbital mechanics which we have used in our orbit to do this. So I just wanted to mention one thing. Now, as you can see, the orbit has become like this. If we go out of the moon sphere of influence, now we are firing retrograde, as you can see, and we are in a moon orbit. As we have decreased the speed enough to do this. So now we are in moon orbit. Okay. So what I wanted to tell, did you observe that when we are not in the moon orbit, the trajectory when it comes out of the moon sphere of influence, it becomes somewhat like this. This is because the gravity of moon pulled us and accelerated, and it reduced our speed as we were moving against the direction the moon was moving. That's why it decreased our speed, and that's why our orbit became like this instead